We've reached the mid-unit, so today I'd like to spend a little time just going and reminding us, reviewing how to graph quadratic equations. We know that an equation is a quadratic equation if it has an x squared. So the power of 2 is what makes a quadratic equation. We've already talked about all of these forms. I just want to review them quickly with you. This first one is called intercept form or factored form. I like this form because if it's an intercept or factored form, there's some things that I can see very easily. If I were to put a 0 where the y value is, then that means I could say that x plus 1 equals 0 or x minus 2 equals 0. So x is negative 1 or x is positive 2. So by putting a 0 where the x is, we've found our zeros or our x-intercepts. So I'm going to say I have one 0 at negative 1 and another 0 at 2. Another name for zeros are the roots or the x-intercepts. If we were solving, we would also call them solutions. So let's plot our point, negative 1, 0 and 2, 0. I know that those 2 points are symmetric. So 1, 2, 3 units between them. If I go 1.5 units in from each point, I'm on my axis of symmetry. So x equals 1/2 would be our axis of symmetry. If that's my axis of symmetry, then I know the x value of the vertex is also 1/2. So then to find the y value, I'm going to go up to the top into this equation, and I'm going to put 1/2 in place of x. So 1/2 plus 1 times 1/2 minus 2 would be 1.5 times negative 1.5, which is negative 2.25. So the vertex is at 1/2, negative 2.25. Somewhere like this. I'm going to go ahead and just draw in my parabola. I'm not going to worry about any more direct points. I am identifying the x-intercepts because I can see that they're nice and clean. We can find x-intercepts even when they aren't clean, but for now we're only going to identify the ones that are. To find the y-intercept, we know that the y-intercept is when we put a 0 for x. So again, I'm going to go back to the top to the equation and put a 0 where x is. So 1 times negative 2 is negative 2. And we can see up here, yep, our graph went through negative 2 on the y-axis. Now let's talk about the domain and the range. The domain is every x value that will produce a y value. So since this graph goes forever in this direction and forever in this direction, there will always be x values. So the domain is negative infinity to infinity. The range is the smallest y value to the biggest y value. The smallest y value that will happen is negative 2.25, and it has a bracket because there is actually a point there to infinity. If I want to talk, and this is something new, we're not necessarily going to assess on it in Algebra 2, but you'll talk about it in Algebra 1, or excuse me, in college algebra. We're going to talk about the domain where this graph is increasing and decreasing. So the domain where it's increasing and decreasing. And if you look at the domain, the x values, as I move from left to right, it looks like this graph is increasing from this point on. So as I move from left to right, when I start at 1/2 and pick points bigger than 1/2, the graph is increasing. So I would say the interval at which this quadratic increases is from 1/2 to infinity. The interval where it decreases in value happens from negative 1/2, excuse me, I said that wrong, negative infinity to 1/2.